Natasha binti Musyariman, and I am going to present about introduction of this topic. What is differentiation? Differentiation in mathematics could be a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by pure algebra manipulation using three basic derivatives, four rules of operation, and a knowledge of how to manipulate function. What is application of differentiation? Differentiation can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular function, such as cost, strength, amount of material used in a building, profit, loss, and others. Derivatives are made in many engineering and science problems, especially when modeling the behavior of moving objects.
A cylindrical can of radius r cm and h cm is to hold 100 pi cm cube of orange juice. The cost of material used for the top and bottom of the can is 4 cents per square centimeter, and the cost of material used for the curved side is 3 cents per square centimeter. For question A, show that the total cost in cents for constructing a can is C equal to 8 pi r square plus 600 pi over r. For this question, given a cylindrical can, we can divide it into 4 parts, top, bottom, and 2 sides. The surface area for this cylinder is 2 pi r square plus 2 pi r h. In this question, it is also given volume for the cylindrical can, which is 100 pi cm cube. We can solve for h using the formula for cylinder volume, which is pi r square h, and we will get h equal to 100 pi over pi r square. Next, insert the h that we just calculate now into the surface area of cylinder equation, which is 2 pi r square plus 2 pi r h, and we will get 2 pi r square plus 2 pi r multiply 100 pi over pi r square. Solve the equation and we will get 2 pi r square plus 200 pi over r. Given in the question is cost for top and bottom, which is 4 cents per square centimeter, and for the curved side is 3 cents per square centimeter. As we know, the top and bottom is 2 pi r square, and we just need to multiply it with 4 cents, and we will get 8 pi r square. For the side, multiply 200 pi over r with 3 cents, and we will get 600 pi over r. At the end, we will get C equal to 8 pi r square plus 600 pi over r.
Hi, I'm Nursa Sabila. Okay, today I will solve the question that is find the dimension of the can such the total cost of the constructing can is a minimum value. So, we need to find the height and radius of the can in a minimum value. Okay, so we go to our first step, that is we need to differentiate the constructing can formula that we got from a question, that is 8 pi r square plus 600 pi over r. Okay, so we will get dc over dr equal to 16 pi r minus 600 pi over r square. So we move to our second step, that is let dc over dr equal to 0. So we will get 16 pi r equal to 600 pi over r square. So we'll multiply 16 pi r with r square becomes 16 pi r cube equal to 600 pi. So we will get the r value equal to 3.347 cm. So we go to our last step, that is to determine our r value, that is minimum or maximum value. So we need to do second derivative, that is we need to differentiate one more time the formula dc over dr. So we will get d square c over dr square equal to 16 pi plus 600 pi over r cube. So we substitute the r value, that is 3.347 in the formula, and we will get 100.45 cm. So we know that 100.54 cm is greater than 0. So the R value is a minimum value. Okay, to find the height of can in a minimum value, we just substitute the R value in the formula hash equal to 100 pi over pi r squared. That's formula we got from a question. Okay, so we will get the height of the can is 8.93 cm. I think that's all for the B question.
Assalamualaikum. I'm going to answer question A, which is to prove the total cost stated. Okay, so in the question, they gave us the volume of the rectangular container, which is 500 cm cube, and stated that the bottom and top container will cost RM1. Meanwhile, for the side, it will cost RM2. Okay, so since they gave us the value of the volume, we need to write down the formula for rectangle, which is x square y. Then substitute the volume with the value 500 earlier, and then we write 500 equal to x cube y to find y. Okay, so after we find y, we need to write down the formula for rectangle area. So the area for rectangle is 2x squared plus 4xy, and then we substitute the y value we got earlier in the question. After we get the area, we need to find the cost. So just take the area, which is 2x squared multiply RM1 for the top and bottom, and then plus 2000 per x, and multiply it with RM2 for the side. So we will get the cost, and then the cost is proven to be the same with the question.
The question is hence find the minimum cost of constructing the container. Okay, to solve this question, first we must find the derivative for equation that given. We put d over dx at all equation. After that, we follow the step to derivative it, such as 2s to the power of 2. When we derivative it, will be 4s, and when 4000 over s will become 4000x to the power of negative 2. So to look nice, we arrange it properly to 4000x to the power of negative 2 equal to 4000 over s to the power of 2. After that, we let d dx equal to 0 to find the value of s. So we solve it step by step, and after we get the value of s is equal to 10, so we change the s into 10 and solve it by using the equation that given in the question. So the answer we get is 600 ringgit.
Our task objective has been achieved. Therefore, we have worked well with each other despite the many challenges we have put into the work. We can interpret the meaning of derivative, why they need to use derivative, and solve maximum and minimum problems. As the whole, it can be said that the concept of differentiation can be used in our daily life in solving problems. Therefore, we thank our lecturer, Madam Jasmani, for providing many encouragement and opportunities for us to complete this group assignment.